All right, so let's look at some of the kind of problems that you're going to have to deal with in the homework. So I'll start with a nice easy one. But it shows how these derivatives are just going to interact with all the other sine rules that you know. So this first one, 3 over t squared. So we have inverse sine of 3 over t squared, right? So what rule are we going to use? Chain rule. And then how are we going to start this though? So like I could treat this as a quotient in here and do quotient rule, but that would be way too much work. So an easier thing for me to do is to rewrite that quotient as a product. So you want to write it as a negative exponent. Whenever your numerator or your denominator is just a constant, don't use the quotient rule. I mean, you can, you'll get the same result, but it's too much work. All right, so now I have y equals inverse sine of 3t to the negative 2. The question just says, find the derivative with respect to the appropriate variable, where there's only one other variable, so it's dy dt. All right, so that equals, okay, so now here's the trick, is I have to take this 3t to the negative 2. That's an inside function, and I need to keep it the same, but I need to keep it the same in here. So what I'm going to have is 1 over the square root of 1 minus 3t to the negative 2 squared, right? So I've substituted that 3t to the negative 2 for the x in my derivative formula. All right, and then, of course, I have to go times the derivative of the inside function. So times g prime, and my g prime is going to be negative 6t to the negative third. So let's make sure we can see that that's a multiplication and not a subtraction. All right, so that's what you've got. Now, this is a mess. Let's clean it up. So I can put the negative up front. We can put the 6 in the numerator. We can put the t cubed in the denominator. And then I have square root of 1 minus 9t to the negative fourth. All right, and that's fine. But if you want, you could write it as negative 6 over t cubed square root of 1 minus 9 over t to the fourth. So there are things that we could do, like, like this is a difference of squares. I don't think that helps much. We could multiply the top and bottom by t squared, and that would cancel out this t fourth in the denominator, but yeah, let's not bother. All right, that's number 5. Let's see if we can squeeze in number 15. So number 15 says, y equals inverse cosecant of x squared plus 1, and x has to be a positive number. Okay, that's declaring that x is a positive number probably has to do with the absolute value that is in our inverse cosecant rule. We have absolute value of x. So we're not going to write absolute value of x because we know x is greater than 0. But we'll have to look carefully how this sort of falls out. Because when I go to do dy dx, is that what they want here? This says find the derivative of y with respect to the appropriate variable. All right, so this time the appropriate variable is x because there's no other variable. That's generally going to be the case here. So inverse cosecant, I'm going to have negative 1 over. All right, now our derivative formula says absolute value of x, but we're going to have absolute value of x squared plus 1. And then we're supposed to have square root of x squared minus 1. Remember, we're substituting x squared plus 1. We're substituting that for the x squared here. So I'm going to have square root of x squared plus 1 squared minus 1. All right, now a little bit's going to simplify in there, so that might be worth playing around with a little bit. But in any case, we have to do times the derivative of the inside, our inside function, right? Remember that inside function is showing up in 2 places, but there's still only one inside function. So that g prime that we're going to put out here is just going to be 2x, so it's times 2x. All right, so now how can we simplify this up? So one thing is, the x greater than 0 doesn't really seem to affect anything because x squared plus 1 is always going to be positive regardless. So we don't need that absolute value of x squared there. But we can put our negative, we can put the 2x in the top, that would be nice. At the bottom, I think something's going to happen. Let's just see. So I can drop the absolute value and just make that x squared plus 1. And then I'm going to have square root of, so the reason I want to expand this out, a lot of times I wouldn't expand this, but I know the 1s are going to cancel. So let's just see what we get when we do that. So I'm going to have x fourth plus 2x squared, plus 1, and then because that minus 1 is still under the square root, that's why they can cancel. If the minus 1 was not under the square root, they could not. So now I have negative 2x over, and then I have x squared plus 1, and then the 1's cancel, so I have square root of x fourth plus 2x squared. So I can't just take the square root of each of these because of the plus sign, but what I can do is factor out an x squared from it. Let's see, so I can say that this equals negative 2x. We might be getting into the territory of it's not worth it anymore. I like this answer a lot. But, you know, part of mathematics is like, can we play around with the forms of things and maybe see if we can find some kind of a simplification that we didn't expect, right? So I just factored out that x squared, and then now I've got 2x over. So here's how the x greater than 0 would be useful to us. Because I'm gonna do the square root of the x squared. Square root of x squared is equal to the absolute value of x. You can verify that if you want. It's not just equal to x. Square root of x squared is not, right? Because x is negative 3. Negative 3 squared is 9. Square root of 9 is 3. So the square root of x squared is the absolute value of x. So that's to simplify this right here. So I have negative x squared plus 1 times what, let's go ahead and write absolute value of x just to be clear that we know that that's what's going on. And then since x is greater than 0, because x is greater than 0, I can drop the absolute value and say this is negative 2x. And here's where this is going to prove to have been worth it, at least arguably worth it if I don't forget my x, right? Is that the x's can cancel now. So I have negative 2 over x squared plus 1 square root of x squared plus 2. So, you know, there you go. That's kind of nice. Okay, so what are you going to do with this? Let's see. I have some things. Oh, we actually have something else to do. We have something else to do. So I'm going to do another video with something else to do.